What's up, guys? Welcome back to another Algebra 2 lesson with Mr. Gaines as we begin a new topic known as geometric sequences. Today, we're going to give you a brief introduction to geometric sequences, so let's get right into it. We have a definition for a geometric sequence. So we just learned about arithmetic sequences, which were sequences in which each term had a common difference, an addition between each term. Geometric sequences are similar. It's a sequence, but it's created by multiplying from one term to the next, or having a common ratio from each successive term. So for example, let's take the number, let's say we start a sequence with, let's say the number 3. And then I multiply that by 2, that would give me 6. I multiply that by 2, that would give me 12. And I multiply that by 2, that would give me 24, and then 48, and so on and so forth. This would be a geometric sequence because each term is multiplied, or is the previous term multiplied by 2. So in problem 1 here, it says determine if the sequence is geometric. And so in A, we have a list of terms. We have 1, 0.5, 0.25, 0.125, and then the sequence could go on and on. So if we want to find out if we have a sequence here, or a geometric sequence, instead of subtracting and finding the difference, we want to divide and find the ratio of the terms. So what I'm going to do here for problem number 1A is I'm going to take A2 and divide by A1. So this would be, you can do this in your calculator if you'd like, 0.5 divided by 1, which is 0.5 or 1/2. And then I could do this again. I could do A3 divided by A2, which could be done in the calculator, 0.25 divided by 0.5, which would also be 1/2. And then I could do A4 divided by A3. So the fourth term divided by the third term. So 0.125 divided by 0.25. And I'd see that this is 1/2. And so is this a geometric sequence? We would say this is geometric. And if we want to go a little bit further, we could say that the ratio, the common ratio, would be 1/2. If I divide each term by the previous term, it is 1/2. Now let's take a look at B. Doing the same thing in B, I'm going to take A sub 2, the second term, divided by A sub 1. And so this gives it to me in fractions, which is okay. I'm going to take 1/4 divided by, making sure I put this in parentheses or use the fraction key here. So 1/4 divided by 1/8 would be 2. And then I'm going to do the third term divided by the second term. So my third term here is, that full size. My third term is 3/4. I'll do 3/4 divided by 1/4. And that would give me 3. So already we see, excuse me, a different ratio. And so this would be not geometric. There may be some kind of sequence, but all we're checking right now is to see if it is geometric or not. Now, if I went a little bit further, I'd notice that the ratio between the fourth term and the third term is also 3. So some of the ratios may be the same, but in order to be geometric, the ratio between each term has to be identical. See if you can pause the video and determine if C is a geometric ratio. Hopefully you were able to discover if C is a geometric ratio. And again, I'm going to write these steps out. So I'm going to take the second term. Notice that we have some sign changes in here. So the sign changes do play a role. So if I have negative 32 divided by 128, that would be negative 1/4. So the second term divided by the first term would be negative 1/4. If I continue this pattern, I'd have 8 divided by negative 32. That is the third term divided by the second term, and that is 1/4. I could do the fourth term as well, divided by the third term. So I'm going to do negative 2 divided by 8, and that's going to turn out to be negative 1/4. And so this is a geometric sequence. And it has the ratio of negative 1/4. So ratios, as we saw with differences, can be positive or negative, but they are values that are multiplied from one term to get the next term successively through the sequence. Let's take a look at another example here. In problem 2, it says, for the following, write the first 5 terms of the geometric sequence with the given information. So what they give us here is that the first term is negative 16. and then the ratio is 0.25. So what we can do here is we can kind of go through a thought process of what a geometric sequence is. It's multiplying each number by the same number, or each term by the same number. So if I do negative 16 times 0.25, or 1/4, it gives me negative 4. I can multiply again by 0.25, or 1/4, and that would give me negative 1. And I could multiply one more time by 0.25, or 1/4, and that would give me negative 1/4. This is the first 4 terms. It did ask for 5, so one more multiplication of 1/4, and I'd have negative 1/16. And we want to make sure we give exact answers here. So you could use decimal approximations. Negative 0.25 would be okay. Negative 0.0125 for 1/16 would be okay. But we want to make sure, or decimal representations, but we want to make sure we give the exact answers and not rounded answers. So these are the first 5 terms that start with negative 16 with a common ratio of 0.25, or 1/4. See if you can pause the video and find the first 5 terms for B. Hopefully you were able to find those 5 terms. So it does start with 2/3. Then we would multiply 2/3 by negative 1/5, and this would become negative 1/15. So again, if you did that in the calculator, if you did 2/3 and have that as a decimal and multiply this by negative 1 divided by 5, it's going to give you a decimal here. So we'd either want to list this as negative 0.13 repeating, or go with the fraction. The fraction is going to be a little bit more common here. So negative 1/15, you can get there by hitting math fraction on the calculator. Sorry, I wrote this down wrong. It should be negative 2/15. Sorry about that. Now we're going to multiply again by negative 1/5, and this would become a positive 2/75. So again, in the calculator, I can do this, multiply by negative 1/5. And it gives me a fraction here. If it gives me a decimal, I would multiply by, or hit math, and then the fraction button. I can do this again, and I'm going to do this real quick, 2 times in succession to get my next 2 terms. So my next term would be negative 2/375, and my final term would be 2/1875. So hopefully you were able to come up with those 5 terms, as a geometric sequence begins with a term, and each term has the same ratio as we go in succession. So this is a geometric sequence. As always, thank you guys for tuning in, and I'll see you soon.